Should record. Page 80. Have you heard of the word electrolyte? Yeah? Okay. Often you'll hear of it in the context of like Gatorade or sports drinks, things like that. Electrolytes are found in Gatorade, in your body, in seawater, in batteries, in plants. Basically, any living creature is going to have electrolytes in it. An electrolyte, you must know this definition. Know the definition. It is a substance that conducts electricity. That's part one. But it doesn't just conduct electricity. It conducts electricity because there is movement of charged particles, but not just any charged particles. Oh, I'm sorry, I shouldn't have put a 2 there. It is due to the presence of freely moving ions. Freely moving ions. So basically, to get freely moving ions, either you need an ionic compound, but if I give you this salt, this ionic compound, it has ions, it has charges, but for current electricity, it has to be the movement. You have to have the movement of charged particles. Are these particles in the solid able to move? No. So if you have a solid ionic compound, it is not able to conduct electricity because it has charged particles, but they cannot move. Okay? So you can have an ionic compound, not solid. But what if I were to melt it? And the particles, what do particles in liquids do? If this is the particle in a solid, what do liquids do? Liquids, are the particles able to move in a liquid? Yes, they are. Yes, liquid. And what if I dissolve this? Do you guys remember what happens when we put a salt into water? Like if I took some NaCl and I dissolved it into water, would I have little NAs attached to Cl's, or what does it look like? If you don't remember, it's okay, because I'm sure there's going to be a picture in just a moment. Okay, so we'll come back to this in a moment. So in order to have current electricity, you have to have moving charged particles. And if you have a copper wire, then the moving particles are electrons. Okay, you might have learned about that in grade 9 or in physics or something like that. But we might have a solution. Okay, when you dissolve an ionic compound in water, it splits apart into the positive and negative ions, which we've covered a couple of times. So let's just show that here. We get Na plus, and it floats around separately from the Cl minus. So we have freely floating ions in solution. So you have moving ions in liquid ionic compounds. You have moving ions in solution, aqueous ionic compounds. So let's take a look at what that looks like. Here we have maybe some sodium, and we have some chloride, and they have been dissolved, so they are floating around separately. Do you remember what it's called when we take the NaCl and it's a solid, and we dissolve it, and it turns into separate ions. Not decomposition. You're close. It does start with a D. Dissociation. Okay? That is different from NaCl goes to Na0 plus Cl2 0. This one over here would be decomposition. And you would get a gas, and you would get the metal, which is a solid. Whereas with the dissociation, they're still in ion form. They are just separate from one another, floating around. Okay? So you can either get it from an ionic compound, and that includes bases, because bases are ionic compounds. So for example, you might have NaOH, that is an ionic compound, which is a base. Or you can get it from acids, because acids actually also dissociate to form freely floating ions. So we might have HCl, and it dissociates in water to form H+ ions, aqueous, and Cl- ions, aqueous. So you get these free floating ions. And the moment you have free floating ions, your solution can conduct a charge. I'm going to do a demo on this tomorrow probably, because we're missing a lot of people today. I'd like for everyone to be able to see it. But basically, if we put a piece of metal into a solution and a piece of metal on the other side, and we attach it to a battery, okay, out of the negative terminal of the battery, the electrons are repelled from the negative terminal, because a negative repels negative, and they move into the metal, and now that metal becomes slightly negative. So what are the positive ions in solution going to do? The positive ions are attracted to the negative metal. And so they're like moving this way, right? They're all trying to get up there beside the negative charge. What are the negative charges doing? Well, again, if we look at our battery, it has a positive terminal over on the right. That positive terminal is attracting electrons that are present in this metal here, and those electrons are moving into the positive terminal of the battery because they're attracted to it. And that leaves behind a positive charge, which is going to attract, this metal attracts the negative ions. So far, so good? Okay. So the moral of the story is, now we have positive and negative charges, and they flow in response to an electric field, which we have. And so if you'll notice, all of the negative charges, the electrons are moving counterclockwise. And the negative charges are completing the journey. They are also moving counterclockwise, and then they'll move up into here and they'll join the electrons going along, okay? It's a little more complicated than that. The negative ions give up their electrons and then they turn into a neutral atom, but we're not going to get that sophisticated until grade 12, okay? The positive ions, on the other hand, are moving counterclockwise because a positive charge moving in the opposite direction is the same as a negative charge moving in one direction. Okay, so this is basically just completing the circuit. You get a full flow of charge. So what do you need in a solution for it to conduct electricity? You need ions. You need dissolved ions. And so to get those dissolved ions, you either need ionic compounds, including bases, or you need acids, because those are the things that dissociate to give you ions. So, what's the takeaway from this? You can have dissolved salts. Those can be electrolytes, because remember, electrolytes have dissolved ions that can move and conduct electricity in solution. Okay, so salts are electrolytes. Also, not just salts, but bases. Salts are ionic compounds, metal and an anion, or ammonium and an anion. And this is what you're going to have to be able to do. You're going to have to be able to recognize that you have an ionic compound because it contains either a metal or it starts with ammonium. And if it contains one of those, and if it is dissolved in water, then your substance will be an electrolyte. Okay? You also need to be able to recognize that electrolytes can be acids. How do we know that we have an acid? Either it starts with H or it ends in COOH. So you are looking, if you're looking for an electrolyte, you are looking to see, does the compound have a metal? Does it have ammonium? Does it start with an H or does it end in COOH? If any of those four things are true, you have an electrolyte. If you have anything else, if you have an alcohol, if you have sugar, if you have glycerol, none of those things are ionic compounds. So let's look at a few examples here. We've got our sodium chloride, right? This is ionic. It starts with a metal. And when we drop it into the water, it dissociates. You should, for this test, be able to write dissociation equations. Remember, it's not the same as decomposition. Your products of dissociation are both aqueous. And they are ions. So the products of dissociation are always aqueous ions. How do you know you're going to get those aqueous ions? Because the compound starts with a metal or NH4 or H, or it ends in COOH. If you have any of those, you are going to get dissociation. Okay? So there's your dissociation equation. You can see these ions are free to move wherever they want to, right? If there's no electric field, they just move randomly. But the moment you put an electric field, the negative ones will move to the positive terminal, the positive ones will move to the negative terminal. So that's an ionic compound. Next page, this is page 82 now. Here is an aqueous acid. You can see that we start with HCl, but in solution, the H's separate from the Cl's and we have freely floating ions. And the dissociation equation for that, you take your HCl, and I would have to give you the state for it. I would have to tell you it's a gas, but because it is dissociation, what are the products of dissociation always? What state are they? Yes, aqueous. And what type of particle are they? They are ions. Okay, so when you're writing a dissociation equation, you want it to be aqueous and you want it to have a charge. Okay? Now, who are the compounds that do not dissociate, that are not electrolytes? Those are our covalent compounds. How do you know you have covalent compounds? Well, we're going to take a look. Basically, if it does not start with a metal, if it does not start with ammonium, if it's not an acid, then it is a covalent compound. Covalent compounds are not electrolytes. They do not dissociate. They simply disperse. Do you guys know what the word disperse means? If you've got a crowd of people and you're like, okay, the event is over, you know, you've given a performance or whatever, and then the crowd disperses, which means they just separate. Okay, they move out. Let's see what that looks like. We have some solid iodine. Each of these particles is an I and an I, and this particle is neutral. It is a molecule. When we dissolve it into the water, every single one of these have a 0 overall charge. Right? It's just iodine. It's not an ion. So are there any charged particles that can move? If there's no charged particles, there's no charged particles that can move. Okay, so basically, this solution will not conduct electricity because there's no charged particles. So this is a non-electrolyte. And you can actually see that the I2 molecules remain unchanged. They're the same in the solid as they are aqueous. They have just separated from one another. So this is what we call a dispersion equation. Dispersion, all you're doing is you're saying it started solid. Here's our I2 solid. And it finished aqueous, but it didn't separate into anything. It's still just I2 aqueous. So a dispersion equation, you should have the same substance before and after. The only thing that changes is that the product is aqueous. So now it's dissolved instead of being a solid, or it's dissolved instead of being a gas. So all covalent solutes are non-electrolytes except for acids. You just have to remember that acids are bizarre and they do separate even though they're molecular compounds. Okay, there's some videos. We're not going to watch those. Basically, so many videos. Feel free to do those. But I think maybe we could do this part tomorrow. Okay, and you guys can work on the stoichiometry for homework. Does that make sense? Okay, so I would like you to, at the very least, have completed limiting reactants with mass. Okay, if not, the other one as well. All right, that'll get you really familiar with limiting reactants. So your homework, at least limiting reactants with mass. And if you have time, you can do limiting with gases, liquids, and solids. Thank you very much. No, you can just pop them right in there as well. And Amir, I've got a couple handouts for you. Sorry. Or did I give them to you already? No, I did not. Okay. So this is what we worked on today. There you go. The answer keys are on the back of them. Okay?
Thank you.
Yeah.
Thank you.
You're welcome.